Dear student, today we're learning about the differentiation. Let's we start from some formulas. So first formula, so derivative of x raised to n is equal to n into x raised to n minus 1. Next formula, the derivative of a raised to x is equal to a raised to x into log of a. So derivative of e raised to x, that is e raised to x into log of e. We know that the log e is equal to 1, so therefore the derivative of e raised to x, that is e raised to x. Next, derivative of log of x is equal to 1 upon x, the constant derivative 0, and root x derivative 1 upon 2 into under root of x. Let's we see some examples based on the formulas. If the derivative of x square is equal to 2x, derivative of x cube is equal to 3x square, derivative of x raised to 4 is equal to 4x cube according to this formula. And for negative power, that is x raised to minus 3 is equal to, according to the formula, so derivative of x raised to minus 3 is minus 3 x raised to minus 3 minus 1, so it becomes minus 3 into x raised to minus 4. So let we solve some example on based on the formula a raised to x. 2 raised to x derivative is equal to 2 raised to x into log of 2, so derivative of 3 raised to x is equal to 3 raised to x into log of 3. Derivative of 2 raised to minus x is equal to minus 1 into 2 raised to minus x into log of 2. The derivative of 2 raised to 2x is equal to 2 into 2 raised to 2x into log of 2. So remember that in derivative the number must be multiplied. The constant number must be taken at the multiplication. Next formula very simple. So derivative of log of x to the base 5 is equal to 1 upon x into log of 5. It depends on the formula log of a to the base b. How to write? That is log a divided by log of b. So now here log 5 is constant, so we take only derivative of log x. Similarly, if the log of x to the base 10, so what is the derivative? So derivative of log x, that is 1 upon x, and the log 10 as it is, that is log of 10. Now it is the constant. Next, let's we remember some derivatives of trigonometric functions. So first is derivative of sine x, that is cos of x. Cos derivative, that is minus sine of x. The derivative of tan x, that is sec square x, and the derivative of sec x, that is sec of x into tan of x. Derivative of cot x, that is minus cosec square x, and the derivative of cosec x, that is minus cosec x into cot x. So we seen some formulas based on that. If the derivative of sine of 2x is equal to 2 into cos of 2x, similarly derivative of cos of 2x is equal to 2 minus 2 into sine of 2x. So what is our observation? Our observation, in the derivative the multiplying constant should be take for the multiplication. And similarly for all remaining, if you consider that, so derivative of tan of 5x, so we get 5 times sec square 5x. So again, what is our observation? The constant multiplying to the function should be take at the multiplication of answer. So now we seen some derivatives of inverse trigonometric functions. So let's we start. The derivative of sine inverse x, that is very simple to remember, 1 upon under root of 1 minus x square. How to remember for sec? Just write down the reverse, that is 1 upon under root of x square minus 1 and take extra x at the multiplication. And the derivative of tan inverse x, very simple, it is very easy to remember, 1 upon 1 plus x square. So what is the derivative for cos, cot inverse x and cosec inverse x? That is for the cos inverse x, only take minus upon under root of 1 minus x square x, again minus 1 upon 1 plus x square. Derivative of cosec inverse x, that is minus 1 upon x into under root of x square minus 1. Very simple to remember. If you remember the derivative for sine inverse x, then you can remember cos inverse x only by taking the minus sign. If you remember for tan inverse x, then take only minus sign. For remember cot inverse x. If you remember for sec inverse x, then only take the minus sign for cosec inverse x. Let's we solve some example based on the addition and subtraction property of derivative. Take the first example, that is y equal to root x plus sine of x minus e raised to x. Differentiating with respect to x, we get apply d by dx on both sides. D by dx of y is equal to d by dx of, write down the example as it is, then apply separately d by dx, that is root x plus d by dx of sine of x minus d by dx of e raised to x. So according to the formula, we already seen the formula. So what is the formula for root x? That is 1 upon 2 root x. Derivative of sine x, that is cos of x, and the derivative of e raised to x, that is e raised to x, and this is dy by dx. So in such way that you can solve the example based on the addition subtraction property of derivative. So let's we solve some more example according to directly CET method. How we solve the example for MST CET. So let we take the example y is equal to 3x raised to 4 plus sec of x minus cos of x plus log of x. So we write directly derivative of, so apply the similar terms, that is differentiate d by dx, apply this separately, and then we get the solution. So we solve directly, that is 3 into, so what is the derivative of x raised to 4, that is 4 into x raised to 3. Derivative of sec x, that is sec of x into tan of x minus derivative of cos of x, that is minus sine of x, and the derivative of log x, that is 1 upon x. In the final step, 3 4s becomes 12, minus minus become plus. Okay, so we get the solution. Next example, we take y is equal to, next example we take y equal to x raised to 10 plus 10 raised to x plus e raised to x. So again similarly taking dy by dx on both sides, apply separately, and then we get, so what is the derivative of x raised to 10, that is 10 into x raised to 9. Derivative of 10 raised to x, that is 10 raised to x into log of 10, and the derivative of e raised to x, that is as it is. We take one more example, that is y equal to 4x square, we take the quadratic equation, minus 3x plus 1. So what is the derivative? Dy by dx is equal to 4 x square derivative, that is 2x, minus 3 into derivative of x, that is 1, and derivative of constant, that is 0. So now we get 4 2s are 8, so 8 times x minus 3. One more example we take for the quadratic, that is y is equal to, into the bracket, 4x square minus 3x plus 1 square. So now here function square, so by using we can solve by using the first formula, that is derivative of x raised to n is equal to n into x raised to n minus 1, then again we take the derivative of x. So similarly dy by dx is equal to, what is the derivative of x raised to n, that is 2 into, write down as it is, that is 2 minus 1 1. So here write down as it is, then the derivative of again d by dx of 4x square minus 3x plus 1. We already solved the derivative, that is 8x minus 3. So therefore the final answer is 2 into 4x square minus 3x plus 1 multiply by derivative of 4x square minus 3x plus 1, that is 8x minus 3. So in such way that we can solve the example based on the addition and subtraction property. Let's we solve some more example. Y equal to, important example for the CET. Y equal to x raised to a plus a raised to x plus e raised to x plus a raised to a. So derivative of y dy by dx is equal to, now this is the function raised to constant, so therefore derivative is a into x raised to a minus 1 plus, now this is the constant raised to function, that is a raised to x into log of a, and the next is derivative of e raised to x, that is e raised to x, and the last, now this is the constant, so constant derivative is 0. One more example we take, y equal to 10 raised to x plus log of x to the base 10 plus log of 10 to the base 10. So what is the derivative? Dy by dx is equal to, now this is the constant raised to function, so therefore 10 raised to x into log of 10, and the derivative of log x, that is 1 upon x, and the log 10 as it is according to the formula, log of a to the base b is equal to log of a divided by log of b, and the last, these are the both are the constants, so therefore the derivative of constant is 0. So we take one more example, y equal to x raised to 5 plus 5 raised to x plus e raised to x. So now the derivative is dy by dx is equal to function raised to constant, that is 5 into x raised to 4 plus 5 raised to x into log of 5 plus e raised to x. So we take one more example, y is equal to log of x to the base 5 plus cos of x plus e raised to x. So now the answer is dy by dx is equal to, so derivative of log x, that is 1 upon x, and 5 log 5 as it is, derivative of cos x, that is minus sine of x, and the e raised to x derivative is as it is e raised to x.